we understood about what is temperature, what is heat energy, correct? Now, how do we measure temperature? Very simple, we use thermometer, correct? Anyone who is sick, the first thing what they do, we take a thermometer, we measure the temperature. See, we measure the temperature. We don't measure the heat energy, isn't it? So, what exactly is the meaning of measuring the temperature? You're trying to figure out how hot or how cold the body is. Correct? So instrument what we use is thermometer, and you have all seen a thermometer. Nowadays we have digital also, correct? But generally, how thermometer works is you have a mercury inside the thermometer, and as the temperature increases, the volume of the mercury inside the thermometer is going to increase. So it rises up. That's the simple logic behind it. All right. Now that we have thermometer, there are different ways of measuring the temperature. Okay, there are different ways of measuring a temperature, and there are different types of units of measurement of temperature. So what we are considering or what we are studying in this particular topic is what units and what measurements we have for temperature. The most commonly used all over the world, the first unit of measurement of temperature, which is degree Celsius, or we can call it a Celsius, all right, or centigrade system of temperature. Okay, now in centigrade or Celsius, what we have is that, see, every measurement of temperature is based on water. Okay, that means we take water, and at what temperature the water is going to freeze, and at what temperature water is going to boil. So these are like a standard points. Okay, now, okay, at this temperature water is freezing, I'll figure out what it is. At this temperature the water is boiling, I'll figure out the temperature. So basically, that freezing point and boiling point are more likely like milestones type. Okay, so it's like a standard measure. So at standard temperature pressure in degree Celsius or in degree centigrade, the freezing point of water becomes 0 degree Celsius, and the boiling point of water becomes 100 degrees Celsius. In the sense, from 0 to 100 we have 100 divisions, correct? That one division is 1 degree Celsius. All right, so degree Celsius is one of the ways of measuring the temperature. The second way is Fahrenheit degree, or degree Fahrenheit is a better way of telling, degree Fahrenheit scale. So in this also, again, the freezing point and boiling point are the standard values. All right. Now, freezing point of water is 32 degree Fahrenheit, and the boiling point is 212 degree Fahrenheit. So between that, there are 180 divisions. All right, this is the Fahrenheit scale. Now, the most thing, see, probably you have seen this also, that we convert degree Celsius to Fahrenheit and everything, correct? So for that, the conversion is very simple. See, you have Tc minus 0 divided by 100 is equal to Tf minus 32 divided by 180. We generally look into this in terms of the number of divisions and the least value. Look at the graph here. See, this graph gives a relation between degree Fahrenheit and degree Celsius. See, 0 degree Celsius is 32 degree Fahrenheit, and 100 degrees 212 degrees. Correct? So this graph clearly gives the relation between degree Celsius and degree Fahrenheit. The next one is called absolute scale. Alright, this is the absolute scale of measuring the temperature. In this, what we do, we take the ideal gas equation, which is PV is equal to nRT, which you guys will get to know it later in the later chapters. You have this in detail. But for now, you have an ideal gas equation. In the sense, ideal gas is, you cannot compress it, the volume changes ideally. Certain cases are there. That's why it's called as an ideal gas. PV is equal to nRT. Pressure P, volume V, N is the number of moles, R is called as the gas constant, and the T is there, no? That is a very, very important point, because that's what we are discussing. T is called as absolute temperature. Now, what exactly is the meaning of absolute temperature? Now, absolute temperature, here Look at this particular graph. See what you have the degree cell, the how the pressure and the temperature is changing, correct? Now, if you look at in the second quadrant, as I lower and lower and lower the temperature, pressure decreases, and pressure becomes zero, isn't it? Now, in an ideal gas, if pressure is equal to zero, the temperature of that gas is called as absolute temperature. Okay, absolute temperature. Now, nothing in this universe can go less than this absolute temperature. Okay, the reason is if temperature becomes less than 0 Kelvin or this absolute zero, the volume becomes negative. See, we cannot have negative volume, quite obvious, isn't it? That's why the least temperature what we can ever go in this universe is 0 Kelvin. So Kelvin is the unit what we use for absolute temperature. Okay. So 0 Kelvin what we have is the lowest possible value, and this temperature is called as absolute zero. So absolute zero is 0 Kelvin, and if we convert that into Celsius, okay, then 0 Kelvin becomes minus 273.15 Kelvin. That 0.15 we generally ignore it, we can just say minus 273. But what if we have to convert from Kelvin to degree Celsius? So T Kelvin is equal to T degree Celsius plus 273.15. Alright, so this is the conversion. Now we have three temperature scales: degree Celsius, degree Fahrenheit, and Kelvin. Guys, never say degree Kelvin. Degree Kelvin is the wrong way of pronunciation the temperature. Okay, should always pronounce it as just Kelvin, not as degree Kelvin. Alright, now three temperature scales: Kelvin, degree Celsius, and degree Fahrenheit. So first we'll see the conversion part now. Okay, so we have Tc minus 0 divided by 100 is equal to Tf minus 32 by 180 is equal to Tk minus 273.15 divided by 100. Alright, these are the three temperature scales, and look at this particular figure. See what you have here, you have the relation between all the three temperature scales, correct? Look at the freezing point, look at the boiling point, and look at the number of divisions what you have. And one more thing is, the SI unit of temperature is Kelvin. Even though degree Celsius is the most used all over the world, again, Kelvin is the one which is the SI unit for temperature. Alright, look at the figure here, you will understand how the temperature is going to vary. Clear? So these are the three scales of temperature, we can call it measurement or scales of temperature: degree Celsius, which is from 0 to 100, degree Fahrenheit, which is from 32 to 212, and then Kelvin, which is from 273.15 to 373.15. Clear? So these are the measurement of temperature.